Okay, we're going to go ahead and make a quadratic model that plots these points. So this is going to be a lot of calculator work today. I recommend using a TI-84, and that's what we use in class. Now, the first thing I'm going to do is I need to enter this data. And for my time interval here, I'm going to call that L1. And for my height, I'm going to call this L2. And what it looks like happening in this problem is a rubber ball is getting thrown in the air. You'll notice as time increases here, my height of my ball in meters is going up, and then it hits a top point here at 1.8 meters roughly, and then it's going to go back down. So I'm assuming it's going to be an open down parabola. So let me go ahead and get my calculator out. I'll move it over here so we have a little room to work. Okay, all of our work when we enter data will be done under the Stat menu, which is right in the middle. Okay, middle column, second button down. And we're going to go ahead and hit Enter. And you'll notice I have already programmed in these two lists. Now, one of the biggest errors you will get if you make a mistake here is you have to have, for every L1 value, you better have an L2 value that goes with it. If you were off by one of these numbers, which happens a lot, that is going to create an error. The next thing I need to do is I'm going to plot some points. So I will go to my window, and you'll notice I changed my window interval as well. My x values over here on this side don't even go up to 1. The largest number in seconds is 0.86 seconds. So you'll notice on my window, I'll go ahead and pull it over here. Let's move that down. Okay, so my window here, I went to 1 for my x max. And same thing here for my y values, my L2. The highest number I have here is roughly 1.8, so I went to 2. And I made my intervals by 0.1, considering most of these are decimals. I thought that made sense. All right, in order for my graph to actually show up, I need to go y equals, I need to make sure that plots here is highlighted. So make sure that you hit enter there. And when I hit graph, these dots should show up. And looking at it, it is a nice smooth curve. And it looks like an upside down quadratic. All right, so I'm going to let the calculator figure out the best line of fit for that. The way I do that is I go to Stat. I go to the right one in Calculate, and I'm going to go down to number 5, and we're going to do quadratic regression. I hit Enter, Enter one more time, and it gives me a lot of data. Okay, let me move this for a second. All right, so you'll notice it does give me an R value, and that R value is very close to 1, so it means it's good data. That's very lined up to a quadratic. But my formula here, if I look at my values, there's an a here that is in front of the x squared, and you'll notice this value goes with a. There is a b here in front of the regular x, and this value goes with b. And then last but not least, there's a c out here with no x value, and this value goes with c. That's kind of a ridiculous amount of decimal places, so we're going to go ahead and just round to 2 decimal places. So if I wrote an equation here, it would be y equals, I'm going to say negative 4.68, we'll round up, x squared, plus 3.76, rounding up, single x. And last but not least, plus 1.04. So again, this is the value for a that goes with the x squared. This is the value of b that goes with the single x. And this is the value for c that is out here without a variable. Okay, next thing I'm going to do is I'm going to go ahead and plot that into my calculator. And I'll hit graph and see if it goes through my points. Okay, here's what I came up with. I typed it into y equals. I'm going to go hit ahead and hit graph and see what it looks like. And, oh, let me double check something. I might have messed up here. Okay, I'm back. I figured out my problem. I forgot the 3.76x. I had no x. So now let's take a look at the graph, and hopefully it goes through my points nicely, and it does. And I came up with an equation. Now that we have this in our y equals, I can use a table to make predictions. So I'm going to scroll down to the second part of this problem. And in fact, I'll go ahead and pull this graph off so we can see that it looks nice and goes through my points. And the last part of this problem, let me move my calculator out of the way here, says, let me scroll up, use the model to predict the height of the ball to the nearest hundredth at 0.6 seconds. So now, since it is typed into y equals, I can use the table, okay, to go ahead and make predictions over here for my height. Now the problem is my table goes by intervals of 1, so I need to change the table settings. So I'm going to go ahead and start at 0, and I'm going to go by intervals of 0.1. So I'll go ahead and pull that off so we can see it in the notes. And now I'll hit table, and you'll notice now I start at 0, and I'm going by intervals of 0.1. And this is the one I'm looking for. Okay, so my answer here would be right here at 0.6 seconds. We'll write it as a coordinate point at 0.6 seconds. Okay, I would expect my height rounded to the nearest hundredth, which is 2 decimal places, to be 1.61 meters. And there's my answer.